Hello everyone and welcome back. We are doing learning curve. Let's do a quick recap of whatever we've done. Let's just pick up one question and the base of learning curve. Let's quickly finish that. Well, the base of learning curve says that whenever there is learning, the more you do something or the more you repeat something, the lesser time it takes to do that. And that relationship we have learnt as the number of units and the average time it takes per unit. So if you give me how long does it take to make the first unit and you tell me what is the average time for the first unit, then I will tell you the average time for keep doubling. So double of 1 is 2, double of 2 is 4, double of 4 is 8, double of 8 is 16 and double of 16 is 32 units. Once this is done, so this is the base. Every question will have this. There is no question will not have this. After this, what they ask changes. Sometimes they only give you labor. In one question that you saw, which was the second question, I think, or the first question that we did. The first question that we did, but was the second question. There they gave you a fixed cost also and so on. So everything will change as and how the question changes, but this baseline will remain the same. I want to now come to questions where we are going to have to do slightly different kind of questions, and that is the first question in your material. What is the question? The question says that in your module it is page 199, question number 1. The question says that the usual learning curve model ax raised to b where okay, I don't know what this is. Let me directly come to the question and read that only. Let A be 10 hours. What is A? The time that it takes for the first unit. Learning curve of 80% and so on. Calculate the average time for 20 units. And this is where my knowledge of learning curve comes to an end. This is where my knowledge of learning curve is restricted. This is where my knowledge of learning curve fails. Why? Because you asked for 20 units. I don't know how to calculate for 20 units. I know what? I know 1, I know 2, I know 4, I know 8, I know 16, I know 32 and so on. 20 units I don't know. Next question. Total time for 30 units. No idea. 30 I can't do. 32 I can do. 30 I can't do. Next question. Total time for 31 to 40 units. Oh, this is intermediate. Well, we've done similar question previously where we actually found the time taken for 9th unit to 32nd unit, which is 24 units that you made in between. Correct? So after the 8, the up till 32 units is what you made, the 24 units. That is the type of question I understand. But how to calculate it, I don't understand. So I want you to stop here and come back to the questions that we did. According to whatever we've done, my understanding of learning curve is restricted to questions asked or questions posed to me for the number of units, 1 unit, 2 unit, 4 unit, 8 unit, 16 unit, 32 unit. Apart from this, if you ask me anything, I won't be able to give you. Well, you will be able to give. How? Understanding what are the things that are related. And that is, if you give me the time for the first unit and you tell me what the learning rate is for any given number of units, I can give you the average time. So if you give me the time for the first unit and the learning curve, then for any given number of units, I will give you the average time. What all did I say in this? Well, I'll tell you. If you give me the time for the first unit, and if you give me the learning rate. For any given number of units, I will give you the average time. The time required for the first unit is called A. The learning rate is called B. The number of units is called X. And the average time per unit is called Y. And how is ABXY related? Well, ABXY is related as the average time per unit is equal to time for the first unit into number of units raised to the learning rate. Or in other words, Y, which is the average time per unit, is A, which is the time for the first unit, into X, which is the number of units, raised to B, which is the learning rate. And with this relationship now, not just for 1, 2, 4, 8, 16, 32 units, for any value of X, I can give you the average time per unit Y. And this is the standard learning curve model that we are going to use for any other question apart from the question where the number of units is not 1, 2, 4, 8, 16, 32. But sir, can I say one thing? If this applies anywhere, shouldn't it apply for questions where I have 2, 4, 8, 16, 32 also? Yes, correct. So sir, can we do one thing? Can we verify this? Yeah, you can do that. With the formula, yes, you can do that. So let's see what we can assume. So if my A is 10 and my learning rate, which is B, which is 80%, then for 8 units, which is my X, the average time should be 5.12, which is my Y. So if I tell you that the first unit took 10 hours and the learning is 80%, for 8 units, find me the average time. And according to this formula also, your answer should be 5.12. Okay, let me verify that for you. Let's begin. What is my learning curve model? My learning curve model is Y is AX raised to B, where Y is the average time per unit, where A is time taken for the first unit, where X is number of units, and B is the learning rate. Okay, so now you are telling me that A, which is the time taken for the first unit, is 10. X, which is for 8 units, you are asking me, and learning rate is 80%. 80% is basically 80 per 100, which is 80 divided by 100, which is 0.8. Then can I say, according to this model, Y is equal to AX raised to B. The average time for 8 units is A, which is 10, X, which is 8, raised to B, which is 0.8. Sir, there is a problem. I can't do 8 raised to 0.8. That's okay. That is my job. I will show you how to do 8 raised to 0.8. So for now, even I am not going to do this in our normal calculators because you can't. I am going to do this in your phone calculators because scientific, much easier. Correct? Perfect. What do you want me to do? You want me to raise 8 to 0.8. Okay. So 8 raised to 0.8. So 8 raise it to 0.8. Okay. I get 5.2780 and so on. Multiply that value by 10. You get 52.78031. I'm writing 52.78. Then can I say y is equal to 52.78. What is y? The average time taken for how many units? For 8 units. Let's check if that is correct. Is the average time for 8 units actually 5.78, 52.78? No, it is 5.12 hours. Then are we not making a mistake? Yes, we are. And where is the mistake? The mistake is that, number one, when they say learning rate is 80%, B does not become 80%. What does B become? B is the log of that 80%. And that log of 80% is taken to the base 2. Why? Let me tell you that B is the log of 80% to the base 2. If I write this in an exponential form, 2 raised to B will give me 80%, or 2 raised to B should be 80%. Why am I taking logs to the base 2? Let's go back to our normal question. 1 is actually 2. You know what 1 is? 1 is 2 raised to 0. What is 2? 2 is 2 raised to 1. What is 4? 4 is 2 raised to 2. What is 8? 8 is 2 raised to 3. What is 16? 2 raised to 4. What is 32? 2 raised to 5. Learning happens to the power of 2. And because learning happens to the power of 2, our learning rate should also be a power of 2. And because our learning rate has to be a power of 2, that is why B, the learning rate, is the log of the learning to the base 2. Which means this whatever I did was wrong, because B does not become 80%. B becomes the log of 80% to the base 2. So let me simplify this. B becomes the log of, what is 80%? 80 is 0.8 to the base 2. B becomes log of 0.8. Now see, log to the base 2 I cannot find. So what am I going to do? I am going to change the base. Log 0.8 divided by log 2, and both are to the base 10. Why? Because I know logs to the base 10. B is log of 0.8. How many places before the decimal? 0. 0 minus 1 is minus 1, or bar 1. Point. What is 0.8 without the decimal? 8. I can't look for 8. Well, then look for 80, because 8 and 80 is the same log. Log of 80 is going to be 9031. So it is going to be bar 1, 0.9031 divided by log of 2. How many places before the decimal? 1. Minus 1 is 0. What is log 2? Well, I don't know log 2, but I know log 20, and log 20 is 3010. So it is going to be 0.3010. So B is bar 1 plus 0.9031 divided by 0.3010, or B is minus 1 plus 0.9031 divided by 0.3010, or B is 0.9031 minus 1, 0.9031 minus 1 is a negative 0.369. So it is a negative 0.969, sorry, divided by 0.3010. When you divide this by 0.3010, what do you get? A negative 0.3219. So I get B is a negative 0.3219. So B is a negative 0.322. And this is the value of B when the learning is 80%. So remember one thing. When they say learning is 80%, the B value doesn't become 80%. When learning is 80%, B is log of 80 to the base 2. Why to the base 2? Because learning happens to the power of 2. Learning happens in the power of 2. 2 raised to 0, 2 raised to 1, 2 raised to 2, which is 1, 2, 4, 8, 16, 32. And that is why it is log of 80% to the base 2, which is log of 0.8 to the base 2, which is bar 1.9031 divided by 0.3010. And this is the simplification. Sir, could I do this in the calculator? Yes. How? You want log of 0.8 to the base 2. Then write it as log of 0.8 to the base 10 divided by log 2 to the base 10. And now do this in your calculator. Now pay attention to what I'm doing, because I'm going to trick your calculator. See, always start with the log in the denominator. Okay, clear your memory and start with the log in the denominator. What do you want log of? 2. So 2. Root sign 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Minus 1. Divided by 0.000070,271. 0.301025. Isn't that correct? 0.3010. Now usually what I would do is write it down. I'm not going to do that. I'm going to add this to memory and let it sit there. I will come to the numerator. Log of 0.8, 0.8, root sign 15 times, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, minus 1, divided by 0.000070,271. This is the log of 0.8, which is a negative 0.9690. Isn't that correct? A negative 0.969. Now divide that by the value in the memory. Divide, recall memory, press equal to. What do you get? A negative 0.3219. A negative 0.3219, which is approximately equal to a negative 3.22. Isn't that the same? And that is how you get the value for B. Now, sir, now can we verify this? Yes, now go ahead. Your A is 10. Your B for 80% is minus 0.322. For X is equal to 8, I want you to find the average time, which is Y. So I will say Y is equal to A X raised to B. Let's finish this off in the calculator. What do I want? I want to raise 8 to a negative 0.322. So 8, raise it to a 0.322 but negative. 0.51192, multiply that by 10 into 10. You get a 5.119. Okay, so I get a 5.119, which approximately is 5.12. I can write. Let's check if I have that. But definitely yes, I have a 5.12. Then does the formula verify? And this is how now I can find the average time for any number of units, not just powers of 2. Any number of units. Well, if it's powers of 2, I don't have to go through all this facade. If it is powers of 2, then it's very easy. But if it is not powers of 2, then I will have to use the formula. And I've showed you that for powers of 2, the formula verifies. I'll show you one more. I will show you that for 16 units, the average time is 4.096. Let me quickly do that. I'm going to write it here only. I'm going to directly say that y is a, which is 10, b, x, which is for 16 units, raised to b, which is minus 0.322. Is that right? So in the calculator, I'm going to say that this is 16 raised to a 0.322 but negative is multiply that by 10. What do you get? Or 4.095. Is that correct? 18. So a 4.09518. What is the actual answer according to your logic? 4.096. Isn't that what we were expecting? The average time for 16 units. Fantastic. And now I was verifying this for you for powers of 2. But now if I tell you, why don't you tell me what will be the average time for 10 units? That also you can tell me. 15 units. That also you can tell me. 18 units. You can tell me. 5 units. You can tell me. Now you can tell me anything. Is that right? Let's continue with questions. So coming back to the question that we were doing. And that is, given that A is 10 and the learning rate is 80%, you are required to calculate the average time for 20 units. Okay. My problem, or let me now read the question completely because now you will understand. And I'll tell you a few things. The usual learning curve model y is equal to ax raised to b, where y is the average time per unit. For x units, a is the time for the first unit, x is the cumulative number of units, and b is the learning curve coefficient. And if you notice, they have given you how b is calculated. And b is equal to log of 0.8 to the base 2, which is log of 80 divided by log of 2, which is minus 0.322. But I have shown you how to do it. So from my end, I have shown you what it means and how it is found. Now in the exam, if they give it to you, fantastic. If they don't give it to you, you know how to find it. But considering they have given it here, they will give it to you there. Also, you will not have to worry. Also, there are only 2 learning rates that you all do. One is an 80% and one is a 90%. And because if it's an 80 and only 90%, it's easy to remember only 2 values. For 80%, it is minus 0.322. And for 90%, we will see what it is. But my point is, I have shown you how to do it. I have shown you the complete working or how that works and why. Let me show it to you once again if you want to write it down. This is it. If the learning rate is 80%, so here write down for a learning rate of 80%, B is log of 80% to the base 2. So B is log of 0.8 to the base 2. B is log 0.8 divided by log 2. B is bar 1.9031 divided by 0.3010 and so on. So B is a negative 0.322. And this is why I wanted you to know how to take the log of numbers where there is nothing on the left hand side of the decimal. So this is your answer for B. Once that is done, you can use this model, which is y is equal to ax raised to b, and for any given value of x, if you give me a, which is what is the time taken for the first unit, and if you give me b, which is the learning rate, then I will tell you what is the average time it takes per unit. Let's come to questions in that case then. Let's come to the first question. and let's read through and through. The usual learning curve model y is equal to ax raised to b, where y is the average time per unit, a is the time taken for the first unit, x is the cumulative number of units, b is the learning coefficient, where b is given by log of 0.8 to the base 2, which is log of 0.8 divided by log 2, which is a negative 0.322 for a learning rate of 80%. Given that a is 10 hours and learning, it should be rare, it should be rate. Learning rate is 80%, you are required to calculate the average time for 20 units. Isn't that easy now? The average time for 30 units and the total time for 30 units and the time taken for 31 to 40 units. So let me get rid of the question from here and let me open the question below. Can I say this is the question that is asked? So let me start with the basic, and that is, because this is not in powers of 2, I can't use the tabular method, I have to use the formula. What is the formula? Y is ax raised to b, where a was given to us. What was a? A was 10 if I am correct. Yes, and learning rate is 80%. So I am going to say a is 10 hours and I am going to say for a learning rate of 80%, the value of b is, and I am going to write it directly because they have given it to us. The value of b is log of the 80% to the base 2, which is log of the 0.8 to the base 2, which is minus 0.322. So you want for the average time for 20 units. So let's come to the first question, and we are going to say that y is equal to ax raised to b. So I'm going to say for x equals 20, y will be a, which is 10, x, which is 20, raised to b, which is minus 0.322. What does y become? Y becomes 20 raised to minus 0.322. So let's pull out our calculators, and I have cancel. I need a 20 raised to a minus 0.322. So 20 raised to a 0.322 but negative. Multiply that by 10 and you have 3.81125. So I am writing 3.811. So y is 3.811 hours. Is the average time for 20 units. Perfect. Next they want is total time for 30 units. So I am going to say for x equals 30. Again the same model. Y is ax raised to b. So the average time, see, I need a total, I understand. But I can't give you total directly. I will give you average and then I will total the average. So y is equal to a, which is 10, x, which is 30, raised to b, which is minus 0.322. So y will be 0.322 30 raise it to 0.322 but negative, 30 raise it to 0.322 but negative. What do I get? I get a 0.3344 and then multiply that by 10. What do you get? You get a 3.34477. So I am stopping at 3.3447. I am writing it as 5 hours. But sir, they didn't ask you the average for 30. They asked you the total for 30. Well, that's okay. I'm going to say average time for 30 units is 3.345 hours. Therefore, total time for 30 units is 3.345 hours into 30, which is, what is 3.345 into 30? 3.345 into 30 is 100.35 hours. Now the next question is a tricky one. And the next question says, I want the time for 31 to 40 units. Now this is weird. How will I give you the time for 31 to 40 units? You give me a number of units and I will give you the time for that. How can I give you time for 31 to 40 units? Simple. Can't you find the time for 40 units? Yes, that I can do. Can't you find the time for 30 units? Yes, that also I can do. In fact, I've done that already. Then find the time for 40 units. Find the time for 30 units. From the 40, remove the time required for 30 units and you will have the time for 31 to 40. Oh, then it's easy. I already have the time for 30 units. To make 30 units, it takes a total of 100.35 hours. All I need is the time for 40 units. So I am going to say for x equals 40, y is equal to ax raised to b. So the average time for 40 units is x. What is x? 40 raised to b, which is minus 0.322. Y is 40 raise it to a negative 0.322. So I have 40, raise it to a 0.322 but negative. This is what I get. Multiply that by 10. 3.0488. I'm going to write it as 3.049. So this becomes 3.049 hours. This is the average time it takes for 40 units. I need total. Total time for 40 units is 3.049 multiplied by 40, and which is 3.049 multiplied by 40 is 121.96 hours. There you have it. For 40 units, it takes me 121.96 hours, in which the first 30 units took how many hours? The first 30 units took 100.35 hours. Okay. Then the remaining. What is remaining? 121.96 minus 100.35, which is the 21.61 extra hours that you took is for unit number 31 till unit number 40. So I will say, therefore, time taken for 31 to 40 units is time required for 40 units minus time required for 30 units, which is 121.96 minus 100.35, which is 21.61 hours. And these are my three answers. My three answers are to question number 1. The average time for 20 units is, what is the average time for 20 units? 3.811 hours. Question B, total time for 30 units was 100.35 hours. And lastly, the third question, and that is time taken for 31 to 40 units is 21.61 hours. Let's check if they also have all this as the answer. Let's begin. So, let's begin with the first question. And the first question is here. Don't look at anything else. Just look at the average time. The average time is 3.812 hours. We got 811. They got 812. That's okay. It's a decimal change in the third place, which is okay. There's nothing wrong with it. Next. The total time for 30 units is 100.35. Perfect. That we have 2 point. The answer is correct till the point. And for the incremental 31 to 40 units, well, the answer is 21.61 hours. Is that right? Yes, 21.61 hours. Then can I say all my three answers tally? And that is average time for 20 units is 3.8112 they got. I got 3.811. For total time for 30 is 100.35 and for 31 to 40 is 21.61. But sir, I have a small problem. You are very conveniently picking up your cell phone and doing this in your cell phone. How do you expect us to do it in the cell phone when we all know that a cell phone will not be allowed in the exam? Will a cell phone be allowed in the exam? No. If a cell phone is not going to be allowed in the exam, how are you expected to do this in the calculator? And this is now the last problem that we solve, and with this learning curve is done. How are we going to manage this? How are we going to manage this value without a cell phone calculator? Let's come back to the formula of learning curve. What does learning curve say? As in how you do something, the time taken, the average time taken keeps reducing by a certain percentage. Okay. So if I ask you the time taken to make 1, 2, 4, 8, 16, 32, 64 units, all I need to tell you is the learning rate and the time for the first unit. But if I suddenly ask you what is the time taken for 15 units, I can tell you 16, 15 I can't tell you. And for 15, I will have to use a formula, and the formula is y is ax raised to b, where y is the average time per unit, a is the time for the first unit, x is the total number of units, and b is the learning curve coefficient. The problem is, in all the questions, this b is going to be a negative decimal. I have taught you how to raise it to powers. I have not taught you how to raise it to negative decimal powers, because you can't do that in your calculator. Your calculator cannot do negative decimal powers. And because your calculator cannot do negative decimal powers, you cannot solve this by yourself. Without the help of a cell phone calculator, you cannot do this. Then what will you do if you want to solve this, or how will you go about this question? Simple. There is one and only one operation that brings a power down. And that power is my biggest problem right now. See, multiplication, divisions I can do, no problem with that. Powers, if you give me integral powers, that also I can do. The problem is this decimal negative power I can't do. Then what will you do in such a case? Well, in such a case, what I will do is I will say taking log on both sides. Log of y is log of ax raised to b. But sir, log has to be taken to a certain base. What base are you taking log to? Well, it's up to you. You can take any base. But what base is convenient to us? 10. So I am taking log on both sides to the base 10. In the next step, I am going to say log of y to the base 10 is, I am going to consider this as log a into b. This entire x raised to b is b. Or in other words, when two values are multiplying, log will change multiplication to addition. So, log of a into b is log a plus log b. So, log of a into b is log a plus log b. Log of y to the base 10 is log a to the base 10 plus log of a raised to b. What is log of a raised to b? Well, the power comes in front and becomes b log a, or logarithms has the power to bring down a power as a coefficient. So this comes down and becomes b log a. And this is the formula you are going to use henceforth to calculate the value of y. And if you want to use this formula, you have to use logarithms. Without logarithms, it is not going to happen. So before I continue the question using this, let me quickly sum this up. In learning curve, two things are very important. Number one, the time taken for the first unit and the learning rate. Once these two things are given, question number 3. For how many units do you want me to find the average time, total time, average cost, total cost? If you want me to find it for 1, 2, 4, 8, 16, or rather, if you want me to find it for number of units that are powers of 2, then I can do this in the table. I don't need anything else. But if you want me to do this for a certain value of x or for a certain number of units that is not a perfect power of 2, then I can't do this. I have to use the ax raised to b method. What is y is ax raised to b method? Well, this is a relationship between the time for the first unit, the number of units, the learning rate, and the average time per unit. And it is given by average time per unit y is a, which is the time for the first unit, into x, which is the number of units, raised to b, which is the learning curve coefficient. What do you mean by learning curve coefficient? If the learning rate is 80%, then b is the log of 80%, but that log is taken to the base 2 because learning happens to the power of 2. And because that is to the base 2, I change the base and find a value and get a value out of it. I will keep that value on one side, but I later realize that that value is a negative decimal and I can't raise to negative decimals without a scientific or without a cell phone calculator. And then I realize the only way I can simplify this is if I take log on both sides. I take log on both sides and I change this relationship into a log based relationship a lot of times. So whatever in pure Hindi bakwas I do, a lot of it is not required. A lot of things are given to you in your notes, or if you want to do a question, there are a lot of things that I say are not required. But I at my heart or in my soul, I really think or I really feel that if you are doing a concept, do it to understand the concept. Don't just do it to write down a formula and start writing it down. Why are we using this? Why can't we use this? Why is B not 80%? Why is B the log of 80? Y to the base 2? All this I want you to know. Although in the exam it will be given to you. Because if in the institute material it is given to you, in the exam also it will be given to you. I taught you logs. Why did I teach you logs? So that you understand this. I wouldn't have taught you logs, and from here if I would directly come here, we would have finished this off. And I would have shown you that they have given you logs in your questions also. The question has logs in it. But because I want you to learn this thoroughly and I want you to be confident in whatever you are doing is why I'm doing this. So tomorrow, if otherwise somebody asks you, what is this? Why is this done? Where is this done? You should be able to tell them what is done and why it is done. Having said that, now henceforth, in a question if the number of units asked or the value of x is not in powers of 2, I will have to use this relationship between a, b, x and y. Let's go to the previous question and start doing it by this method. Let's go back to the question, and I'm again going to read it from scratch. What does the question say? The question says, to begin with, that the usual learning curve model will apply. What is the learning curve model? Y is equal to x raised to b, where y is the average time per unit for x units, a is the time for the first unit, x is the cumulative number of units, b is the learning coefficient, and is log of 0.8 to the base 2, which is minus 0.322 for a learning rate of 80%. Given that A is 10 hours and learning rate is 80%, you are required to calculate the average time for 20 units. The moment I read average time for 20 units, I come to a realization that I cannot do this in the powers of 2 criteria, because 20 is not a power of 2. What are powers of 2? 1 is a power of 2, 2 is a power of 2, 4 is a power of 2, 8 is a power of 2, 16, 32 are powers of 2, 20 is not a power of 2. So the moment I realize that, I have to understand that I can't do it in a table, I have to use the formula. After I realize that I have to use the formula, I realize that I cannot use the formula with the standard sense of the formula, because in that formula I have y is equal to ax raised to b. So I will say I can't use this taking log on both sides. Now this, if you want to show, you can show. If you don't want to show, it's okay. And we have y log y is log a plus b log x. And then we start substituting whatever we know. So let me write down the particulars for this particular question. Now see, the value of A always remains the same throughout the question. A never changes. The time taken for the first unit will always remain the same. The learning rate throughout the question always remains the same. What changes is, for a given value of x, y will keep changing. So x and y are the two variables. These two are constants. That is why they have written as x and y. This is written as a and b. So what we are going to do is, we are going to create a standard formula for the value of A is 10 and B is minus 0.322 with this relationship. So I'm going to say in the next step, log y to the base 10 is log A to the base 10 plus B log of x to the base 10. Which in the next step becomes log of y to the base 10. Y is a variable. Log of A is a constant value, 10 to the base 10, plus B, which is minus 0.322 log of x to the base 10. So then for a given value of x, I will find y. Let me do one thing. Let me simplify this and write it a little. So I'm going to say log of y to the base 10 is, what is log 10 to the base 10? 1. So in this case, it is special, so it becomes 1. It is not always that it might become 1. So I'm going to say 1, positive, negative, negative. 0.322 log of x to the base 10. And this is the standard formula for this kind of a question, or this is the standard formula for this question. Now, for any given value of x, I can find y. I want to find for 20 units for x equals 20. I will say log of y to the base 10 is 1 minus 0.322 log of x, which is 20 to the base 10. You know how to find log of 20 to the base 10? Yes. What will you say? 2 places before the decimal. 2 minus 1 is 1. Point. What is the log of 20? Look in your sheet. It will be 0.3010. So it will be 1.3010. But why go through all that hassle when they have already given you the values? And what are they? They have done something very cunning. What I require is the log of 20. Have they given you log of 20? No. They have given you the log of 2. And I have told this to you. Log of 2 and log of 20 is the same. This is exactly why I did logarithms with you all. So that you don't get stuck at any point. There is nothing that I haven't taught you. Log 20 and log 2 will be the same value. The mantissa will remain the same. The characteristic will change. And I will say log y to the base 10 is 1 minus 0.322 into. If log 2 is 0.301, log 20 will be 2 places before the decimal minus 1 is 1. Point. Log of 20 and log of 2 will be the same, which is 0.301. Or you can finish it in the calculator also, because it logged to the base 10. You could have found log 20 in your calculator, you would have got 1.301. So you are 100% sure that whatever you are writing is correct. 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, minus 1, divided by 0.000070271. 1.301. Perfect. 1.301. That is exactly what we were looking for. All we have to do now is simplify. Multiply the 0.322 with the 1.301. 0.322 into 1.301 is 0.418922. So I get log of y to the base 10 is 1 minus 0.418922. So 1 minus 0.418922, 1 minus 0.418922 is 0.581078. So I get log of y to the base 10 is 0.581078. 1 minute. I didn't ask you to find log of y. I asked you to find the value of y. Or then we'll have to take anti-log. Taking anti-log on both sides. Now because I don't have place, I'm writing it here because I don't want to waste. Log of, anti-log of log y is the anti-log of 0.581078. Anti-log of log y will nullify the effect and become y is the anti-log of 0.581078. And they've given you the anti-log of 0.5811, which is almost the same as 0.5810. 0.078. What is the anti-log? The anti-log is 3.812. 3.812. So the value of y is 3.812. Is that correct? Did I get the same value previously? Yes. Just some time ago I had done the same question, but I used my cell phone calculator and the answer is y is 3.811 and here I got 3.812. Isn't it the same? Yes. But how did I do this? Without using the cell phone calculator. That is the first question. Let's come to the second, which is, you want me to find the total time it takes for how many units? 30 units. Fine. Let's begin. What do I have? I have created a standard formula for this now. And what is my standard formula? Well, my standard formula is that log of, for this question, log of y is 1 minus 0.322 log x. So I'm going to use that only. Log of y is 1 minus 0.322 log x to the base 10. So I'm going to say for x equals 30. I will have log of y to the base 10 is 1 minus 0.322 log of 30, which in the next step becomes log y to the base 10 is 1 minus 0.322 into, how do you find log of 30? Well, if they give you the log table, 2 places before the decimal, minus 1 is 1. So 1 point log of 30, which is 4771. But I won't do that. They have given me logs. Let me check if that has log of 30. Oh, very smart. This does not have log of 30. It has log of 3. But can I say log 30 and log 3 will be the same? The only difference is in log 30, the characteristic will be, in log 3, the characteristic will be 0. In log 30, the characteristic will be 1. So if log 3 is 0.4771, then log 30 is 1.4771. Don't believe me? Check it. 30. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Minus 1 divided by 0.000070271. 0.4771. Perfect. 0.4771. Let's start. 0.4771 into 0.322. 1.4771 771 into 0.322. 0.4756262. So log y to the base 10 is 1 minus 0.4756262. Subtract 1. Now I'm doing a reverse subtraction. I'm doing minus 1 and I know the answer will be negative, but it should be positive because I have done a reverse subtraction. So the answer is 0.5243738. So log of y to the base 10 is 0.5243738. Correct? But I don't want log y. I want y. Taking anti-log on both sides. Anti-log of log y to the base 10 is anti-log of 0.5243738. Anti-log of log will become y is the anti-log of 0.5243738. How do you find anti-log? Go to your log table, not required. They've given you anti-log. What is the anti-log of 0.5243? Oh, they haven't given 0.5243. They've approximated it to 4 digits and made this 0.5244. An anti-log of 0.5244 is 3.345. So y is equal to 3.345. Is that correct? Yes. R's is the average time it takes to make 30 units. So, therefore, total time for 30 units is 3.345 hours into 30, which is 3.345 into 30 will give you a 100.35. So it is going to be 100.35 hours. Is that what I got some time ago? Yes, we just did this some time ago. But what did I do? I directly did this in my cell phone calculator. But I got the same answer, 100.35 hours. We come to the last part of the question, which I have explained it to you what they mean, but let's run through once again. The time for units 31 to 40. They want you to find the time for units 31 to 40. Well, I can't give you 31 to 40 directly because the formula that I have designed gives me from 0 up till that point. So when I put 40, it will give me the time taken to start from 0 units and make 40 units. The formula that I have designed, if you ask me for 35 units, then it will give me the time it takes to start at 0 and make 35 units. So it gives me the total time from scratch. They don't want time from scratch. They want an intermediate time. What do they want? What they want is, they are saying that if you want me to give you 31 to 40 units, according to my formula, I can give you 0 to 40 units. According to my formula, I can give you 0 to 30 units also. And you want 31 to 40, then from 0 to 40, subtract 0 to 30, and you will get the time for 31 to 40. So for this, I need to find the total time for 40, because the total time for 30 I have, which is 100.35 hours. So I will go back. I have the formula with me. What is the formula? Log y is equal to 1 minus 0.322 log x. So I will go back to the formula. And for this specific question, the log of y is 1 minus 0.322 log of x. So I will say for x is 40 units. I can give you the average time required to make 40 units. I will say log of y to the base 10 is 1 minus 0.322 log of 40 to the base 10. What is the log of 40 to the base 10? Well, if I had a log table, I would have said 2 places before the decimal, minus 1 is 1. So it is 1 point. Look for 40. Without the decimal is also 40. 40 will be the, I think, 6022, if I'm correct. 0.6022. So the answer should be 1.6022. But they have not given you log 40. They have given you log 4. But that's okay. See, in 4, there is 1 place before the decimal, so characteristic is 0. In 40, there are 2 places before the decimal, so the characteristic is 1. So I will say log y to the base 10 is 1 minus 0.322 into log of 40. Log of 40 is, if log of 4 is 0.6021, then log of 40 is 1.6021. I have to simplify this. Log of y to the base 10 is 1 minus 0.322 into 1.6021 is 0.5158762, 0.5158762. Subtract 1 from it and you will get a 0.484128. But this is log y. I didn't ask you log y. I asked you y. Taking anti-log antilog of log y is the antilog of 0.4841238. Antilog of log y is y. Antilog of 0.4841238 will be, what is the antilog of 0.4841? They've stopped at 4841. That's okay. It is 3.049. And this is average time required to make how many units? 40 units. So what am I going to say? I'm going to say therefore total time for 40 units is 3.049 hours into 40, which is 3.049 into 40 is 121.96. So let's go back. For 40 units, it requires 121.96 hours. So here, for the total 40, 121.96 hours. So for this incremental, from the 121.96 hours for 40 units, remove the 100.35 hours for 30 units. What will you get? 121.96 minus 100.35 is 21.61. So it is 21.61. So I will go back and I will say time taken to make 31 to 40 units is time taken to make 40 units minus time taken to make 30 units, which is 121.96 minus 100.35 hours, which is 21.61 hours. Always make sure that at the end of it, make sure you below everything, yes, highlight this so that it's visible, and at the end of it, make sure that you write it down verbally. 1, 2, 3. Average time taken to make 20 units is 100.35 hours. Average time taken to make 20 units is, yes, 3.812 hours. Total time required to make 30 units is 100.35 hours. And then the time taken to make 31 to 40 units is 21.61 hours. This is my solution. I will keep it on for some time. So always start with this, write down this. Then for this question with A as 10 and B as minus 0.322, create your own formula and then start calculating. This is for the first question, average time for 20 units. This is for the second question, total time for 30 units. And the third and the last question, time required to make 31 to 40 units. And these were the answers we checked. The only difference was previously when I did it using my cell phone calculator, and now I have done it directly. So let's verify. 31.12 correct, 100.35 correct, and 21.61 correct. That's it. That is question number 1. Question number 1 is done. Question number 2 is also done. That was one of the initial questions. Question number 3 is not done. Question number 4 is done. And question number 5 was again the repetition of question number 2. So that is also done. So we are now left with one question, and that is question number 3. Let's come to question number 3. Let's come to the one last question that is left, and we are done with learning curve. It's a slightly loaded question. There is a lot that is happening, a lot that is asked. So please pay attention. I'm going to read the question from start to end, and then we are going to break it into parts. The question says that ZPLC experienced difficulty in their budgeting process because it finds it necessary to qualify the learning effect as new products are introduced. Substantial product changes occur and result in need of retraining. An order of 30 units of a new product has been received by ZPLC. So far, 14 have been completed. The first unit required 40 direct labor hours, and the total of 240 direct labor hours have been recorded for 14 units. The production manager expects an 80% learning effect for this type of work. The company used standard absorption costing, the direct cost attributed to the center in which the unit is manufactured, and its direct material costs are as follows. Direct material 30 per hour per unit, direct labor rupees 6 per hour, variable overhead 0.5 per direct labor hour, fixed overheads is 6,000 rupees per 4-week operating period. There are 10 direct employees working 5-day week, 8 hours per day. Personal and other downtime allowances account to 25% of the total available time. The company usually quotes a 4-week delivery period for its orders. You are required to, number 1, determine whether the assumption of 80% learning effect is a reasonable one. In this case, by using the standard formula y is equal to ax raised to b, where y is the cumulative average direct labor time per unit, ax is the cumulative number of batches, A is the average labor time per unit for the first batch, x is the cumulative number of batches produced, b is the index of learning. Number 2, calculate the number of direct labor hours likely to be required for an expected second order of 20 units. And number 3, use the cost data given to produce an estimated product cost for the initial order. Examine the problem which may be created for budgeting by the presence of learning effect. So we've read the question. Let me break down the question one at a time. It's a very big question, because of which what happens is, by the time you reach the bottom, what you read in the top is forgotten. So now let's break it one at a time, and we will answer it one at a time. ZPLC is experiencing difficulty in its budgeting process because it finds it necessary to qualify a learning effect as new products are introduced. Substantial product changes occur and result in need of retraining. So what is happening? There is an organization called ZPLC. They make a product, and what happens is they are finding it difficult to budget the product. What do you mean by budget? Like decide on capacity, decide on manpower, material, and all of that. Why is it happening? Because they believe that this product follows a learning curve effect. And because this product follows a learning curve effect, they are not able to exactly estimate the time it will require to produce a certain number of units, because of which budgeting is becoming a problem. But my question to you is, how do you know that there is learning curve effect because of which it is becoming a problem to budget? Second line. An order of 30 units of a new product has been received. So they've received an order of 30 units. Okay. So far 14 have been completed. Okay. So you've received an order of 30 units. You've started producing it. And you have produced how many units? 14 units. Okay. The first unit required 40 direct labor hours. So when you started producing, the first unit that you produced took 40 direct labor hours. Okay. And a total of 240 direct labor hours was recorded for 14 units. Okay. So the first unit required 40 hours and 14 units required 240 hours. Well, let me tell you something. If the first unit required 40 hours, if the first unit required 40 hours, then if you are telling me that the first article took 40 hours and you have made 14, is that correct? So if the first article takes 40 hours, then 14 articles should take 40 into 14. What is 40 into 14? 40 into 14 is 560 hours. But what are they saying? How much time is these 14 articles actually taking? Let's go back. First unit takes 40 direct labor hours and a total of 240 hours has been recorded for 14 units. See, according to my calculation, if one unit takes 40 or the first unit took 40 hours, then 14 should be 14 into 40, which is 560. But actually, it has taken only 240 hours. Then can I say one thing? Then can I say learning curve is being applied, or a learning is being followed, because of which the time taken to do is reduced. 240 total. So average will be 240 by 14. What is 240 by 14? 240 divided by 14 is 17.14 hours. 17.14 hours. Do you notice that the first article took 40 hours and now the average time to make 14 is 17.14 hours, which definitely means that learning is happening. And as the work is repeated, as the number of articles made is increasing, the average time is decreasing. And if that is true, they are saying what? They are saying that the production manager expects an 80% learning effect for this work. So, is he sure the learning is 80%? No. He is expecting the learning to be 80%. Is that right? Stop right there and directly come to the first question. Determine whether the assumption of 80% learning is a reasonable one. So what are they saying? They are saying the manager is expecting the learning to be 80%. My question is the learning 80%? Or in other words, can I say, I have to prove that the learning is 80%. There are two methods of doing this. Your institute has followed one. I'm going to show you both. You can stick to whatever you think you are more comfortable with. Let's begin. What data do I have? Well, the data that I have is, number one, A, which is the first unit that I made, took 40 hours. Correct? 40 hours for how many units? 14 units. Is that right? The learning, I don't know. I have to find what the learning is. And if it is 80%, then the manager's assumption is correct. But what am I going to judge this on? Well, I'm going to judge this on something very simple. I am going to say that total time for 14 units is 240 hours. Therefore, average time for 14 units is 240 by 14 hours, which is, what is 240 by 14? 240 divided by 14 is 17.1428, or can I say it is 17.143, is 17.143 hours. So what do I have? I know that A is 40, I know that X is 14, I know that Y, which is the average time, is 17.143. I have to find the value of B. I know the usual learning curve model. What is the usual learning curve model? The usual learning curve model is Y is equal to AX raised to B. I can't work with this because the powers become a problem. So I'm going to say the log based relationship is log Y to the base 10 is log of A to the base 10 plus B log of X. You can either remember it or you can apply log on both sides and start applying log rules. Now when I start substituting log of Y, what is Y? 17.143 to the base 10 is equal to log of A, which is 40 to the base 10, plus B, which I have to find, log X. What is X? 14 to the base 10. Now when you look into this question, and this is why I prefer teaching you logarithms. If you look at this question, they've done something very inhuman, and that is they have directly written everything. No logs are used. In the entire question, they have not used logs anywhere. Y is equal to 40 into 30 raised to minus 0.332 is 13.80 directly. How, when, how? No idea. And that is why I have taught you logs. So there is a good chance that they will give you logs. But then I would expect you to know those logs. I have taught you logs, so no problem with that. Let's begin. Log of 17.143. Two places before the decimal, 2 minus 1 is 1. Point. In your log sheets, 17.143. So under 17, 1. 1 is 2330. So 2330 plus 17.143. Oh, 4 digits. Fifth digit is also there, but it's 3. I'm going to cancel it out and I'm only going to look for 17.14. So in 17, I will look for 1. And in that, I will add the mean difference of 4, which is 10. So 2330 plus 10 will be 2340. And that's your answer. 1.2340 is log of 40. 2 places before the decimal, minus 1 is 1 point. 40 will be, in 40, look for 0. In 40, 0 is 6021. That's your answer, 6021. Plus B. What is the log of 14? 2 places before the decimal, minus 1 is 1 point. 14 will be, in 14 I am looking for 0. 14, 6, 1, so 1461. So the answer is 1461. Now it's just pure simplification. Take this to the other side, and also if you want to check, quickly check in your calculator if the logs are correct. Log of 17.14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Root sign 15 times, minus 1. Divided by 0.000070271. It's 1.2340. 1.2340. Perfect. Log of 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, minus 1. Divided by 0.000070271. 1.6021, 1.6021, perfect. And log of 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, minus 1, divided by 0.000070271. 1.1461, 1.1461. So everything works perfect. Take this to the other side and subtract. So 1.2340 minus 1.6021. 1.6021 minus 0.3681 minus 0.3681 is B into 1.1461. Goes to the other side and divides. So a negative 0.3681, which is already there in my calculator, divided by 1.1461 divided by 1.1461, and it is a negative 0.321176. So it is a negative 0.321176 is B, or B is a negative 0.32. I am approximating this and writing it as 3212. Isn't this 0.322? And you know that the learning curve for 80% is 0.322, which means it's correct, no? But we can't declare it. We will continue. What is B? B is the log of 0.8 to the base 2 is minus 0.3, sorry. What is B? B is the log of the learning rate to the base 2. So it is the log of the learning rate to the base 2 is minus 0.3212. So in the next step, change of base theorem. What does the change of base theorem say? Change of base theorem says that this will be log of learning rate to the base 10 divided by log of 2 to the base 10 is a minus 0.3212. Cross multiply. Log of the learning rate to the base 10 is minus 0.3212 multiplied by log of 2 to the base 10. Is that correct? Yes. Can I say which in the next step will become? Log of the learning rate to the base 10 is minus 0.3212 multiplied by the log of 2. Which in the next step will become? What is log of 2? One place before the decimal, 0 point. I will look for 203010. Multiply the 2. What will you get? Well, what you will get is 0.3010 multiplied by 0.3212 is a negative 0. So log of the learning rate to the base 10 is a negative 0.09668112. Correct? Now I have to take anti-log on both sides. The problem with the anti-log is that I won't be able to take an anti-log with a negative here. So I have to change this into bar. So I'm going to say log of the learning rate to the base 10 is 1, a positive 1, a negative 1, minus 0.096682. Let the positive 1 add with this. So make this negative and add the 1 to it. So you will get a negative 1 plus 0.9033188. Negative 1 is nothing else but bar 1.9033. I'm not writing the 188. And this is the log of the learning rate to the base 10. Taking anti-log on both sides, anti-log of the learning rate to the base 10 is bar 1.9033. Anti-log of bar 1.9033. So the learning rate, because the log and the anti-log nullifies each other, the learning rate is given by anti-log of bar 1.9033. Correct? My mantissa is 0.9033. So I will look for the anti-log of 0.9033. So in the 0.90, I am looking for 3, which is 7998, and in that I am looking for 3, which is 6. So 7998 plus 6. 7998 plus 6. 7998 plus 6 is 8004. So the learning rate is 8004. Characteristic is -1. -1 plus 1 is 0. So how many places before the decimal? 0 places. 0.8004. If the learning rate is 0.8004, can say the learning rate is nothing else but 80.04%. Or can I say the learning rate is approximately 80%? Can I then say that the manager's assumption is correct? Because I got the value of the learning rate as 80%. This is one way you can go full-fledged. If you think this is too cumbersome, do one thing. Stop right here. And after that, write down that for a learning rate of 80%, B is minus 0.3212, which we know. And that is why the manager's assumption that the learning rate is 80% is a correct assumption. There is one more way of going about it, which your institute material has done, and they followed it because it is obviously the correct or the easier method. What have they done? But what they've done is something very simple. They have said that let us assume that the learning rate is 80%. So, for a learning of 80%, what is your value of B? B is a negative 0.322. So I am going to say y is equal to ax raised to b is log terms written as log y is to the base 10 is log a to the base 10 plus b log of x to the base 10. Now see, I know that a is 40. I know that I am making 14 units and I am assuming that my learning rate is 80%. So b is a negative 0.322. So I am going to say that log of y is log of a, which is 40 to the base 10 plus b, which is minus 0.322 into log of x, which is 14 to the base 10. So log of y to the base 10 is log of 40, and we just did log of 40, so I don't want to find that again. 1.6021, so 1.6021 minus 0.322 log of 14. We just found log of 14, which is 1.1461. 1.1461. So in the next step, log of y to the base 10 is 1.6021 minus, multiply the two, what do you get? A 0.322 multiplied by 1461. What do you get? A 0.3690442. 0.3690442. Subtract. Now I'm doing a reverse subtraction, so please understand. 6021, so minus 1.6021. I will get negative. There's nothing wrong with that. Log y to the base 10 is 1.233058. I'm not writing it. 1.330. But I didn't ask you to find y. I didn't ask you to find log y. I asked you to find y. So I will say taking anti-log on both sides, the anti-log of log y to the base 10 is the anti-log of 1.2330. Anti-log of log is y. Anti-log of 1.2330. So what is my mantissa? 0.2330. I will look for the anti-log of that. 0.2330. So in 0.2, I am going to look for 3. In 0.23 is 1710.233. So 1710. Okay. So the anti-log is 1710. Characteristic is 1. So number of places before the decimal is 1 plus 1, which is 2. So the average time it should take for 14 units, if the learning rate is 80%, is 17.10. But they have not given me the average time for 14 units. They have given me the total. So I will say, since the average time for 14 units is 17.10 hours. Thank you, sorry. Therefore, total time for 14 units is 17.10 into 14 hours. What is 17.10 into 14? 17.10 into 14 is going to be 239.4. 239.4 hours. Well, can't I say that is approximately 240 hours? Oh, you also got 240 with the assumption of 80% learning, which means the assumption is a correct assumption, which means the manager's hunch that there is an 80% learning is a true assumption. Therefore, the assumption that the learning is 80% is a correct assumption. And that is how the module does it. They don't find the value, they assume the value, and with the help of the assumed value, they start checking if what they got and what we are getting is same or not. If it is the same, then the assumption is a correct assumption. That is question number 1. Let's see how the material has done it. I told you they've done it in this way. What have they said? But they've done it very wrongly. They've not used logs, which is not possible. You know what they've said? The total time for 14 units, assuming the learning curve. So they found the total time and they got 240. So if they got 240, which means it is true that the learning ratio is 80% is effective. So the assumption that the learning rate is 80% is a correct assumption. But the way they have done it is wrong. Please don't follow that method, because you won't be able to do it in the exam anyway if you try to follow that method. Let's come to the second part of the question. What does the question say? Calculate the number of direct labor hours likely to be required for an expected second order of 20 units. Oh, so second order of 20 units is placed and you want me to do that? Oh, this is a little confusing. Second order. So let's go back to the top. What does it say? What it says is that an order of 30 units of a new product has been received. Oh, so the first order is 30 units. What do you want me to do? You want me to calculate the number of direct labor hours likely to be required for an expected second order of 20 units. So, of the same product. So, the production will continue after the first 30 units. How will that work? I'll show you. What you will do is, you will produce the first 30 units and then continue to produce the rest of the units. So you will produce the first 30 units and then continue to produce the next order of 20, which means 50. And like I told you, I can't give you intermediate time. And these kind of questions are asked a lot. So what do? Simple. I can find the total time for 50 units. I can find the total time for 30 units. This whatever is left is your second order of 20 units. So what do I need? I need two things. The total time required for 50 units, which is the first order of 20 and the first order of 30 units and the second order of 20 units, which is total of 50 units, of which I need to know how long did it take for the first 30, because I only want the time for the next 20. So the first thing that I'm going to do, I'm going to find for 50, then I'm going to find for 30. How? Well, everything is in place now. A for this question is 40. The learning rate is minus 0.322, and now I can use it because I proved it to you just some time ago that the manager's assumption is a correct assumption. So I can use this rate now for all the questions because there is an 80% learning rate. So I will say the y is equal to ax raised to b becomes log y is log a plus b log of x. Now let me make this standard equation standard for this question. So I will say for this question log y will be log of 40 plus minus 0.322 log of x. So log of y will be log 40. We just found log 40 a lot of times. And log of 40 is 1.6021. So it is 1.6021 minus 0.322 log of x. And this is my standard formula, you can say, for this kind of a question or for this question. What do you want? I want you to find the total time for 50 units and the total time for 30 units. Okay. For x equals 50. Log y is 1.6021 minus 0.322 log of x, which is 50. Log of y will be 1.6021 minus log of 50 0.322 0.322 log 50 will be 50. Two places before the decimal, minus 1 is 1. 50 will be, in 50 I will look for 0. In 50, 0 is 6990. So this will become 1.6990, which will become log of y is 1.6021 minus 0.322 into 1.6990 is 0.547078. Correct? Subtracted from the 1.6021. Now I'm doing a reverse subtraction, so I will get a negative value, which is a negative 1.055022. So it is 1.055022. But I didn't ask you log y, I asked you y. Before taking anti-log on both sides, let me make this a 4-digit. 0550. Taking anti-log of log y is anti-log of 1.0550. So y is 0.0550. Anti-log of 0.05. Let's go to anti-log. 0.05 ka 5, 1135. So the answer is 1135. Characteristic is 1. 1 plus 1, 2. 2 places before the decimal. So it is 11.35. What you can also do is, if you want, you can take anti-log in your calculators also. You do the exact reverse what you did for log. What do you do for log? You first press the root sign 15 times. Correct, sorry. You press the root sign 15 times. You subtract 1 and then you divide it by 0.000070271. You do the exact reverse for anti-log. Instead of dividing, multiply. Go from down. So if I want to take the anti-log of 1.0550, first multiply it by 0.000070271. Then instead of subtracting 1, add 1. And instead of taking a root 15 times, press into equal to 15 times. See, when you are raising it, you press into equal to, no? So opposite of root is squaring. So if you are taking root 15 times, now you have to square this value 15 times. So you do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 11.3497, which is 11.35, and that's your answer. So 11.35 hours is the average time for 50 units. So can I say therefore total time for 50 units is 11.35 into 50, which is, what is 11.35 into 50? 567.5 hours. So it is 567.5 hours. This is the total time for all the 50 units, which is the first order of 30 and then the repeat order of 20. I want to now find how much did the first order of 30 take. So then I will know what the repeat order of 20 will take. So first I will write down my equation. What was it? Log y is 1.6021 minus 0.322 log of x. So I am going to say for x equals 30. Log y is 1.6021 minus 0.322 log of x, which is 30. Log of y is 1.6021 minus 0.322 log of 30. How do you find log of 30? How many places before the decimal? 2. Minus 1 is 1 point. Log of 30 will be 30 ka 0, which is 4771 if I am right. Yes. Simplify. Log of y is equal to. So 0.322, multiply that with 1.4771 is 1.6021 minus 0.4756262. Subtract from 1.6021. Subtract 1.6021. Negative I know because I'm doing a reverse subtraction. Log y is 1.1264738. But I have to take an anti-log, so I need only 4 digits. 1, 2, 3, 4. Well, let me approximate this and make this 5. Log y is 1.1265. Taking anti-log on both sides, anti-log of log y is the anti-log of 1.1265. So y is the anti-log of 1.1265. If you want to, you can do it in the calculator and finish it off. So then you can cross check if their value of anti-log and your value of anti-log is correct or not. 1.1265, correct? Number 1 multiplied by 0.000070271. Add 1 to it and then into equal to 15 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 13.38 is their answer. So let me write this in the side. 13.38. Let me see if I get the same taking anti-log. I will take the anti-log of the decimal part, which is 0.1265. So in your anti-log sheet, 0.12, in that 6, which is 1337, and in that 5, am I right? 0.1265, yes. 0.126, in that 5. 5 is 2. So it is 1337 plus 2, which is 1339. So y is 1339. Characteristic is 1 plus 1. 2 places before the decimal. So 13.39 or y is 13.39 hours. So the average time it takes to make how many units? To make 30 units is 13.39 hours. Isn't it the same that we got? 13.388 actually we got. Approximate is 13.39. Now, therefore, total time for 30 units is 13.39 into 30, which is 401.7. Done? So, to make 500 units, it took 570, to make 50 units, it took 576 hours, in which it took 401 hours to make the first 30 units. So that incremental, or let me draw it for you. The total 50 took 567.5, out of which the 30 took 401.7 hours, which means this pending incremental 20 units will take whatever is left. So what is left? 567.5 minus 401.7. 165.8 hours. So 165.8 hours. Let me write it down. Time taken for the second order of 20 units is time taken for 50 units minus time taken for the first 30. I don't have the space, so I'm not writing this down. So please write it down. 567.5 minus 401.7, which is 165.8 hours. is your answer. Let's check if they also have the same. The solution to question number 2 begins here. 30 units, it takes average of 13.380 hours, which is also, ours is also correct. We got 13.39 hours, that's okay. For 50 units, this is the average. So for 30 units total is 401.4. We got 401.7. They're getting 401.4. Total time for 50 units is 567.5. We got 567.3. They're getting 567.5. That's okay. So the incremental will take 166.1. We got 165.8. That is because, see, they are doing calculations directly. We are doing calculations using log. So it's okay if there is a little bit of a difference here and there. No problem with that. Is that right? So question B is also done. Let me quickly rewind it for you. What does it mean? They are saying that you are getting a second order of 20 units. How long is it going to take to finish that second order? Well, I need to know the first order. Well, they wrote in the question that the first order is 30 units. Now understand. People make a mistake by thinking that the first order is 14 units. No, it's not. See, the first order was 30 units, of which 14 were made. 14 units were already made, but the order was 30 units. So first order of 30, second order of 20, total of 50 unit order. They want you to tell them only the 20 unit incremental time. So you say that, find the total 50, find the total time for 50 units, find the time for the first 30 units, subtract, you will get the incremental time for 20. And that was the second part of the question. Let's come to the third and the last bit. What does the last part of the question say? Let's go back up. And the last question, which is the third question, says that use the cost data given to produce an estimated product cost for the initial order. Examine the problems which may be created for budgeting by the presence of learning curve effect. Now this second part is the theory question. The first part is what we can do. Use the cost data given to produce an estimated product cost for the initial order. What is the initial order? Well, the initial order of 30 units. An order of 30 units. They are asking you to find the cost of this 30 units. For the cost of these 30 units, I need to know the time for these 30 units, which I already have. Didn't I just do this in that question? Yes. I already have the time taken for 30 units. Didn't I just do that? Yes. What is the time taken for the 30 units? The time taken for 30 units is a total of 401.7 hours. So if this is the total time taken, they are asking you to do cost. Okay. So I have to understand what all are the costs that are involved. Let's go back to the question. Let's look at the costs that are involved. Cost number 1 is direct material cost. So let me write that down. Direct material is 30 per unit. Cost number 2 is direct labor is 6 per hour. Then variable overheads is 0.50 per labor hour. Okay, so 0.50 per hour. And lastly, fixed overhead is 6,000 for a 4-week operation. Fine. Pretty simple. Let's begin. Direct material, see, I'm making 30 units. So material is applied directly. No learning is applied on material. 1 unit 30 rupees. Then 30 units, 30 into 30 rupees straight. No two ways about that. Labor is whatever time it took. It took 401.7 hours into 6 per hour is your labor. Variable overheads, it is also hourly. It took 401.7 hours. Multiply that by 0.5. That is your variable overheads. The fixed overheads is 6,000 for a 4-week operation. 1 minute. You are charging 6,000 for 4-week period and we are using standard costing. Now you must have done standard costing, standard absorption costing, must have not done. I'm not teaching costing here, I'm just teaching a bit of costing. So I don't want to elaborate and waste too much time on what standard absorption costing is. It's also called TAC, which is TAC, which is total absorption costing, whatever. It basically means that I am going to pay you for what I am using. Whatever per hourly is given, I'm going to pay you for that. Bottom line is, you are charging 6,000 for a 4-week operation. My question is, am I using your premises for 4 weeks? Well, I don't know. If I'm using for 4 weeks, no, then take money for 4 weeks. But if I'm not using for 4 weeks, why will I pay for 4 weeks? Like for example, this you are charging for 4 weeks and imagine my production is done in 1 week. Rest of the 3 weeks, you are using your facility to produce something else. Why do I pay for the rest of the 3 weeks? And that is why, if you come back to the question, they have given you something in detail, and that is, there are 10 direct employees working 5-day weeks, 8 hours per day, personal and other downtime allowance according to 25% of the available time. So let me write that down. What am I writing? 10 workers working for 5-day week, working for 8 hours per day. Is that right? And there is a 25% down time. Why? Well, I've allowed them a downtime of 25%. They are working, they are doing physical labor, they get tired, sometimes they have to use the washroom, electricity is not there, raw material has to be used. So I'm giving them a 25% downtime. So let me understand this well. You are charging me 6,000 for a 4-week operation. Is that right? Let me find out how much work goes through in a 4-week operation. There are 10 workers working 5-day week. So in 1 week they work for 5 days. But I want to know for 4 weeks, so into 4, into 8 hours per day is a total of, you can do it directly also, 5 4s are 20, 20 into 2 is 16, so 160, 160 into 10 is 1600 hours. So in a 4-week period, 1600 hours worth of work is done, out of which 25% is downtime, minus 25% down, which is 1600 minus 25% of down is 1200. So can I say in a week, in a 4-week period, the hours that are put in is 1200. Am I using all 1200 hours? I am only using 401 hours. Why do I pay you for all 1200? Then let's do one thing. What? I am charging you 6,000 rupees for 1200 hours basically. Correct? Then what am I charging you for 1 hour? Cross multiply. What do you get? Or let's say x. X is equal to, this will go here, this will come here, 6,000 divided by 1200, which is 6,000 divided by 1200 is 5 rupees. So it's basically costing me 5 rupees per hour. So the fixed overhead is coming out to be 5 rupees per hour. Let me repeat this. Material is direct. As many units you make, multiply. Labor will depend on how many hours you've worked for. Variable overheads are also hourly, so that is also how many hours you worked for. Fixed overheads, they are saying it is 6,000 rupees for a 4-week operation. But is my operation a 4-week operation? Well, I don't know. Well, then let's find out, what do you mean by a 4-week operation? Well, a 4-week operation means 10 workers working for 4 weeks, 5 days a week for 8 hours. So which means a 4-week operation is 1600 hours. But there is 25% downtime, which means a 4-week operation is 1200 hours. Which means I am charging you 6,000 rupees for 1200 hours. But 1 minute. I'm not using it for 1200 hours. I'm only using it for 401 hours. Well then fine. Let me find the per hourly rate and then I will charge you that way. So overheads is 5 rupees per hour. So let's go back and let's start doing the calculations again. But this time doing the calculation simultaneously. And that is, let me unzoom this a little so that we can see more. And that is direct material is rupees 30 per unit. So the total direct material will be 30 units I am making into 30 rupees is 900 rupees. Done? Next. Direct labor is 6 rupees per hour. Direct labor is rupees 6 per hour, which is rupees 6 into how many hours am I using the facility? I am using it for 401.6 hours right here. 401.7 hours, sorry. So into 401.7 hours, which becomes 401.7 into 6 rupees is 2410.2. So this comes to 2410.2 rupees. Next is variable overheads is 50 paise per hour. Variable overheads is rupees 0.5 per hour, which is rupees 0.5 into 401.7, which is 401.7 into 0.5, which is 200.85. So it is rupees 200.85. Next, last, which is the fixed overhead. We realize that fixed overhead comes out to be 5 rupees per hour. So fixed overheads is rupees 5 per hour, which is rupees 5 into 401.7, which becomes 401.7 into 5 is 2008.5. So it is 2008 rupees. So the total of the totals is 2008.5 plus 200.85 plus 2410.2 plus 900 is 5519.55 is the total cost. Let's see if the institute material has that as well. 5519.5. 55, yes, the answer will be a little different because like I said, their final total cost was different. Total time was different. So the last part, they have 5516.1 because their total hours was 401.4. Ours was 401.7. That is why they have that small difference. They have 551 6.1, but that's okay. That's it. That is the last question, which is the last question in learning curve. That's it. I've taught you logs. I taught you how to take logs, anti-logs in the sheet as well as in the calculator. Why? Because I want to be safe, because there is a question where they've written logs, there is a question where they've not written logs. Just in case there is a problem, you know how to solve the question. The standard framework of the question remains the same. You might have two types of questions. One's where the number of units fits in powers of 2. If that's the case, then you don't have to do anything. Just write them down in powers of 2 and then start taking a percentage of the average and then find the total, whatever. If it does not fit in that framework, then you have to go to the log bit of it. I've showed you all different aspects of whatever and however these questions can be done. I hope you've understood. I will try to incorporate, if at all I can, more questions. But for now, I would want you to stick to the institute questions, these 4 questions, because like I said, if they ask you from the material itself, they don't ask anything else. Well, with this, the chapter learning curve comes to a sweet end. Thank you very much. And I don't know if I'm doing anything else in this paper. I doubt if I'm doing anything else in this paper. But yes, thank you very much. Bye.